Welcome to this video on the Model Context Protocol 2026 specification and AI governance. We will cover the architecture evolution, stateless core updates, enterprise security implications, and governance guardrails for autonomous AI agent ecosystems. How do we guide assistants we can't see? We need AI governance, or rules for controlling smart systems. This MCP 2026 spec, our System Connection Protocol, updates our design. Think of self-running assistants as capsules flying through office tubes. Control the pipes. Don't just watch the mail. So you must build safe channels. Control the pipes, not the paper. But how do we grow this network? The MCP 2026-07-28 specification marks a major transition for the protocol, moving from local, single-user developer sessions toward cloud-native, enterprise-scale AI integration infrastructure. How to mail things without locked lines. Architectural modernization, or design update, swaps persistent stateful connection handshakes, or open pipes, for a stateless protocol core on HTTP/Kubernetes infrastructure, or standard servers. For protocol efficiency, or speed, we use multi-round-trip requests, or checks, standardized header routing, or stamps, and cacheable list results, or lists. Enterprise extensions add MCP apps, server-rendered UI components, or widgets in client conversation threads. Tasks and OAuth support asynchronous background tasks, or jobs, and enterprise-managed authorization via zero-touch OAuth 2.1. These are key release highlights. Pipes stay open. But how do we... Why did our old communication tube choke when too many letters arrived? Under the shift to stateless core and infrastructure-first design, legacy MCP, our old tools, bottlenecked. This relied on STIO, or standard streams, and persistent sessions, or open lines, choking enterprise load balancers, our traffic directors. This 2026-07-28 release cuts protocol-level sessions, or alive rules. Instead, every request is self-contained with explicit token validation, checking keys every time, matching cloud-native API gateway architectures, or cloud entrance designs. Self-contained letters never clog. So you shift to stateless cores. But what other widgets can travel inside this newly freed pipe? How can we show users rich charts without breaking conversation flow? In new specification features, MCP apps or screens safely draw interactive UI widgets or boxes in agent conversations. Tasks extension managers formalize long-running asynchronous agent workflows or delayed paths for background jobs without keeping client connections open indefinitely. Enterprise Auth, or company security, aligns with OAuth 2.1 and OpenID global rules. This features resource indicators, or targets, centralized discovery, or master directories, and explicit audience validation. Deliver tools directly in conversation, so you build rich experiences. But why does this change how we manage all risk? Understanding these changes is crucial for security officers and risk managers. It is essential to treat the Model Context Protocol as an infrastructure layer control plane. How do we build secure walls around random pipes? We need governance control points. Integration standardization, or uniform rules, swaps fragmented ad hoc API integrations, or messy patches, for an auditable protocol substrate, a trackable base across AI agents. Infrastructure layer guardrails, or fences, move access from brittle application code, or weak rules, to centralized API gateways and proxy layers, our checkpoints. Non-human identity and delegation, or passports, binds tasks to user identity, or human credentials, via per-client consent registries, or permits, and scoped permissions, or limited rights. standardized connections to secure flow. So you lock your gates. But how do our pipeline operators know if a capsule contains a harmless letter or something dangerous? This introduces risk and tool annotations, or danger stickers on packages. In our pneumatic mailroom, we must label every canister before it flies. A green sticker means safe reading materials. A red skull stamp means a destructive tool that changes files. Without these danger stickers, our gatekeepers cannot block hazardous cargo before it enters the vault. Annotations let us declare risk levels, so gates block bad requests automatically. Label the tool before you unleash the power, so you label every action clearly before execution. But what happens when a canister slips past our safety stamps? For 100% safety, our stateless security standard uses per-request token validation, checking keys, and rejection of token pass-through. We ban HTTP session cookies and generic token pass-through for per-request authorization, stopping confused deputy vulnerabilities or tricked users, and stale session exploitation or old logins. So you verify keys. Check every key. But what governance teams must monitor critical risk vectors in production deployments. Being proactive about these factors is essential for maintaining a secure, agentic environment. What happens when a bad actor slips a malicious note into our clean mail tubes? This agentic risk vector map charts threats. First, indirect prompt injection, or malicious external instructions, targets models. Second, shadow MCP servers, or unmonitored servers, create silent entries if missed by continuous network inventory active scans. Third, confused deputy vulnerabilities, tricking software to reuse keys, lack token audience validation, and odd claim checks. Fourth, async task abuse, or overloading background work, lacks real-time oversight. Clerks install secret mail pipes. So you treat all input as untrusted. Treat all external data as untrusted. Pause. But how to build our final roadmap? How to turn warnings into a concrete checklist. This is the actionable roadmap for AI teams. First, for inventory and audit, or finding parts, discover all MCP hosts, clients, servers, and tools in local and cloud environments. Second, for gateway policy entry rules, enforce OAuth 2.1, per-request token checks, and audience validation at API proxies. Third, for least privilege, minimum rights, enforce tool annotations, allow lists, and mandatory human approvals for destructive tools. Fourth, for telemetry and DLP, log tool calls to SIAM, SOAR, and apply egress masking before data enters model context. We register tubes and gates, so you use this roadmap. Secure the pipes. But how do we continue? Thank you for watching this breakdown of the MCP 2026 specification. If you found it valuable, please like, share, and subscribe for more deep dives. Feel free to leave your questions in the comments below.